Hi, hello everyone, and welcome to this session. Currently, we are live, so we will be presenting this session today here at API Specification Conference 2021. So I really welcome you to the session. I hope you can stop by and share with us for the following minutes, where we will be talking about a very interesting topic. It is event-driven APIs and how the data schema governance is required for this kind of new APIs that are starting to raise in our ecosystem. So let's get started, and you will be able to add some questions on the Q&A on the right side of your window. Also, you can use the chat if you want to continue the conversation. I will share with you some links and some information at the end of the session. And if there's plenty of time, we might be able to do a quick demo and showcase some of the features that we have been doing around this specific topic. Okay, a little bit more about me. My name is Hugo. I'm a Mexican currently based in Massachusetts in the United States, and I work with Red Hat as part of the APIs and event-driven solutions called Red Hat Integration. And I'm an open source advocate. I do love history, travel, and I consider myself a food enthusiast. So if you really want to continue the conversation or check what we are publishing and whether we are sharing, there's the Twitter handler that you can follow then, or you can also search our YouTube channel, or you can also check what we post at the zone or the developer site at Red Hat. So the three topics that we're going to be covering in the following minutes, it's going to be a quick intro to event-driven APIs and what are the challenges when we talk about specifically about Kafka, Apache Kafka. We're going to be going into the contract first approach and what are the challenges and what are the different things that we can do around event-driven applications. And finally, how these event schemas as part of Kafka need to be managed because they become the contracts that we will be covering. So let's start with the first point. So event-driven APIs and modern applications. So what does this mean? Currently, we do have applications that needs to cover all these three options. Being highly distributed, meaning they need to be running across not just different nodes or different VMs, but across different data centers and located in different regions even, or even different clouds. And those applications needs to be decoupled. That means that they need to be able to connect with applications that are independent in the technology and the protocols, but also in time. And that's one specific thing. When we usually try the decoupled part, we talk about the technology, but not the time. So time is also one of the things we want to be able to decouple up our applications, where you have an application that it's not even running when some event happened or some information is being shared, and it could retrieve that information lately. And then those need to be highly connected because no single application lives in the vacuum. So we will need to be able to connect all our applications with each other. And for that, we have been doing different things in the last 10, 15 years. We have been seeing a shift into microservices. And then after that, a big switch from point-to-point communications to request response patterns. And that was mainly REST APIs that were the solution to build connectivity on top of a very interesting protocol like HTTP, and being able to easily have this protocol understand that is human readable and at the HTTP level. And then finally, we also have the rise of events of event-driven architecture. And actually, that's the topic for today. We're going to be focusing on this type of application and architecture patterns for this. And as you have seen for the title of this talk, we are going to be focusing on the Apache Kafka side of the event-driven architecture. We know that there's different type of events, and there's also different types of event consumption patterns. So depending on what type of consumption pattern your application has, one type of broker, another can be used. And in the case of Apache Kafka, when you need a high throughput and you need replayable events that are able to be reread or received after they were read the first time, that's one of the things what you will be looking for when implementing Kafka. However, that has some trade-offs. And currently on the Kafka ecosystem, we have found that we have been facing this kind of Kafkaesque uh, um, side, and it is because sometimes when we are deploying these now applications that are connecting through Kafka through that API, we suddenly find that there are some missing pieces there here and there. So one of the things that we have seen is sometimes the endpoint documentation it's not well established, it's not well shared within teams, and also information on the data schema, the format and the validation that needs to be done at the Kafka level sometimes leads to some misunderstanding of where is the endpoint, what type of data do I need to send, and we just see application crashing, and that's one of the challenges. The other challenge that we have in this Kafka's world is also the infrastructure access. Where is it available or not? Can we use unmocking? Are the events available? What are the type of events that I will be receiving? Like what are the examples that I will be getting? And also, one important thing, and this is going to be focusing later in this session, is how can we make our publisher and consumers compliant with the structures and the schemas that we want to share within our topics. Because if one of those are not strong enough, they start to create these problems of a slow time to market or poor quality in our code with applications crashing or just miscommunication that just takes longer to continue and to develop. And there's why we have seen that event-driven APIs, so APIs that allow us to share events as part of the event-driven architecture, require contracts. And the contracts can be either contract-first approach or code-first approach. But the important thing is that we will need to have those contracts. So why, for example, contract first? That it's something I think most of us have been also advocating as a way to do parallelization of the work and to reduce the times. Well, it's because it allows people to work independently. You can get consistency on the data that you are transferring. You will have strong guarantees on these service contracts because these contracts put in front what are the structures and the endpoints and everything. So it is very easy to collaborate in the design, and then just each one of the members of the team or the teams being able to do their own implementation. And we have created a lot of generators and tooling around those contracts, so we are able to save a little bit more of time or help us to do linked validation or auto generate code from these contracts, or even doing testing. So in the REST world, when we have the traditional synchronous APIs or REST APIs, we have something like the OpenAPI specification, where the contract becomes this specification. We use this specification to build a contract, and that same contract um, can be designed from scratch on a blog node, or we can use some tooling like Apicurio Studio that allows us to create these specifications using web form base, or we can use things like micros that allows us to do contract testing, as well as mocking of the events and the APIs that we have around um, around these applications. And this is for the REST APIs. So when we're talking about traditional HTTP communication, these are the kind of things that we have been using in the past. When we move into event-driven APIs or asynchronous APIs, in the past we used to have everything doing manually or doing with very um, manual tasks and manual activities. So the idea from a group of people around the AsyncAPI specification has made the work to bring some of those features that we have in the REST API world into the event-driven APIs through the Async API. So it is a open source way to share event-driven architectures. It was created mainly to describe these event-driven APIs. So basically, how do I interact as a consumer, as a producer with a broker, and being able to find information, do the discovery of the structure and the representation of my broker. So it is heavily influenced by the OpenAPI specification. They just joined as part of the foundation, and they're available to in their version 2.2. So it is evolving. They have been working together with several different partners, including Postman. That is where most of the people are working within. And the idea of the Async API is being able to reflect this kind of a specification where you define your APIs. And the idea is where we will have this kind of seamless data transfer between the traditional contracts on the REST API side, as well as on the asynchronous API. So if you notice, when we do a registration or when we do orders or when we do inventory, most of the times, without depending on implementation of the API, most of the times those business objects will be the exact same ones, because there's no actual difference. We're still talking about the same order, we're talking about the same user, we're talking about the same registration or item and such. So the idea of having a control over the data structure of our APIs, it's one of the motivations for looking into a way to handle these kind of payloads. And if you go into the detail of the Async API, that will help us to give it some form to the event-driven APIs, you will see that there's different sections. If you have already worked with OpenAPI, you will see that there's metadata information. There's some information on the service or the authentication mechanisms. You will see the channels with the operations that you will be able to reach. And in the case of Kafka, our channels represent our topics. And the interesting thing here is the message part. So one of the things that the Async API specification has is that it allows us to use different useful formats to define the structure of our message. So Async API defines the framework of reference for our specification, but also within the specification, we can use our commonly used encoding or serializers for using Async API or JSON schemas or Avro or protobuf for that. And that makes it very flexible for us to define the structure and then reuse the structure that we either already have in our Kafka ecosystem or just be able to share with other consumers or other providers that will be using this one. And this is why we say that the schemas are the events contract. So when we are talking about the Sync API specification, and we want to focus specifically on Apache Kafka, the CML for the contract is the schema. So when we send information into our Kafka topic, the schema is the one that will tell us what is the structure of the message and how we will be serializing and deserializing that information. So let's see a quick example of what happens usually when we don't put schemas on as first-class citizens. So imagine you have two applications. You have a application that acts as a producer that will be sending information into your Kafka topic, so your Kafka cluster, and then you have another application that will be consuming those events. So if those applications are within the same team, for example, your team owns both applications, doing any change on the structure of the message will certainly pass your integration test and will certainly pass your unit testing. But what happens when suddenly your topic needs to share the same information with other consumers? And suddenly you realize that those consumers are not part anymore from your team, and they're now external teams that you need to share information with them. So it's the exact same approach when we suddenly realize that we have APIs and we need to share them with our developer portal. So when we are doing this kind of approach, and we need to do an update on the structure of the schema, or adding a field or changing one of the file types, because remember, this is business oriented infrastructure, and we have to reflect the changes also in the business. So if you have suddenly an update on the version and you have now version 2 available in your system, and your producer sending information with this new structure, there might be some time where your consumers are able to get the new schema. For example, if you're using Avro, and then being able to update their code, so they're now are able to deserialize the information that is coming on those topics using this new version that you share by email or on the GitHub repo and such. But if suddenly you have a consumer that is not aware of that change, and suddenly start to see that they are receiving information or data that has a different structure, was, well, perhaps for the applications that are receiving the same version, it's going to be okay. But for that one that is receiving in an old version or a different version of the structure, most of the times they will just fail, and we will need to handle errors and do some recovery to be able to continue consuming those messages. And that will certainly come with the service disruption and perhaps a bad experience for the users of those applications. So what we have seen here in this simple scenario is that in the Kafka world, we need to address certain challenges. If you remember, Kafka is really not aware of the data types or of the schema formats. One of the things that made Kafka really great for scaling and for being able to handle millions of messages, it's that it just receives an array of bytes, and it's very efficient to handle those. So it has delegated to the consumers and the producers this serialization of the data, and making them understandable within applications. It's sending that logic into consumers and producers to the clients. And that then gets into the problem that our API schemas are subject to change. As we mentioned, the business changing, we need to add no new fields, we need to deprecate fields and such. So our structure and the format where we're using our own on our topics will change with the time. And we also need to be able to handle those without causing this kind of disruption. And for that, it's where we are advocating for a central registry where we can have these schemas stored and that are accessible for any producer or consumer to be able to retrieve the information to successfully process the data that is flowing through your topics. And this is why we need a registry for even the schemas, and not just for schemas, but let's focus on that as this is part of the Kafka ecosystem. So in this case, when we add this concept of a registry for governing the different schemas that we have available, allows us to have this central piece of software that we can use as a reference, and where we can apply certain access control modes, and also some compliance validations for updating the different schemas that we have available. So in this case, we see that in the top of the screen, we see that the registry can have a reference using, for example, the topic name. In this case, topic A, topic B, and topic C. And each one of those topics is using a different serialization format or uh, different schema, and then those are available there, and we can then have producers and consumers being able to retrieve that information from the registry and then use those schemas to generate their code and also use them as part of their serializers and deserializers for getting the right structure for the messages. So in this case, the serializer in the producer can go and retrieve the information from the schema for the topic A, and then search by the name or by the D. There are different strategies for that. Then get the schema back, serialize the information, and then send it back to the topic. In the exact same way, the consumer can then read those messages coming from the topic and then check what is the identifier that was used for serializing this data, and then go to the registry and then retrieve the information, get that into this deserializer, and then use that to deserialize the events and the messages that are coming in that place. So the registry needs to have some capabilities to also being able to successfully govern these schemas, right? So the first is obviously you need to have some artifact management. You need to be able to store you store your schemas and you store your information there, updates, deletes, access control, and such. You need to be able to handle different data formats because having just the registry that only handles one kind of a type of schemas, it's going to be limiting. And so you need to be as broader as possible to handle Google protocol buffers or JSON schema or Avro schemas. And important is to be able to do this kind of versioning, where you're able to have different to track the evolution of your different schemas and check which version it is using for that. So you can continue to send information on the same topic. So you don't need to be jumping between versions and getting your data from the exact same topic. You just need to keep the version of the that you use for each one of your events. So for that, a registry needs to be able to handle schemas, need to be able to handle API designs, and also being able to share some of your data types. And I'm going to share you a simple example, for example, of one of the registries that we have. So as in the community, there are different type of registry. Related to Kafka, we do have the Confluent registry. IBM also has one of the registry for events. More recently, the cloud providers are also working around the registry for their own services and their own platform. Azure Event Hub also have some registries. In the case of AWS, they are also working alongside this the exact same idea. And in my case, I'm going to be showing you the Apicurio Registry. So this is part of the Apicurio community, where you can get the studio that I just mentioned, and you can just edit and play around, or you can have the registry that is this piece that allows to have different objects stored, like OpenAPI, GraphQL, protocol buffers, the AsyncAPI, where you can see the content of your API. In this case, we can also upload new artifacts for that. So in this case, I'm gonna upload a couple of artifacts from my environment. So let's go to our comments, and then now I have terminal. Let's create some schemas there. So in this case, what I have, I'm uploading manually to the registry my schemas. You can also use some of the toolings like a Maven plugin. In my case, I'm just going to be using HTTP curl command for this. My registry is running on port 8080. So with this, I'm just going to be posting my B1 version of the schema, and now it is available. So if I go back to my registry and I just do refresh here, I should be able to see now my event. And this is the format of my event. It's an Avro schema, very simple event that has two versions currently. So I have version 1 that has the just two fields like the name and the description, and then I uploaded a second version of my of my um, of my event, and then it should be able to see there's a third field that it's called source. It can be it's optional, so it can be null or string. So in this case, I have checked the compatibility of the new version. So in this case, because it is optional field and it's not a breaking change, I was able to update a second version. You can enable some rules for validation or compatibility, so you can enforce that breaking change is not allowed to update the version, because it will certainly produce some errors. In this case, I don't have those enabled, but I would check that it was possible to continue reading the information. So now that I have my events available in the registry, then I can go to my applications. And for Kafka clients, it's very simple to implement the registry. So in this case, I have a legacy Spring application that is using the Spring templates for this. And the configuration for this, it's pretty simple. So what we need to do is use the producer template, obviously connect with my local host that it's used running Kafka, and we can just add the properties for the Apicurio registry. One important thing is that we are using here the serializer from the Apicurio registry. So they are providing some serializers that allow us to simplify the access to the registry. So we just need to pass the configuration of the registry, the strategy, and the version. So in this case, the Spring application is going to be using the version 1 from my registry. So we will be able to search for the record ID name and then check the specific version. So on the consumer side, we're going to be doing the exact same thing, and we're going to be connecting to the registry. Then I have another application that it's now running on Quarkus, and the configuration is very similar. I just need to pass the URL of the application. In this case, Quarkus is using the messaging, the small right messaging profile from MicroProfile, and it's based on also on Kafka, also using the serializer from Apicurio Registry, and we are going to be finding the latest version of the schema. And also you can see that I have commented the auto register. So I just mentioned that there are different ways to upload your schemas depending on what is your process. I just upload them using HTTP, but you can use the Maven plugin, or you can even allow your applications to register their own schemas. And finally, I also have a consumer. And for that, I also have a third application that it's running Kafka streams. So it's a Kafka streams application that is reading from two topics. And again, able to configure the registry URL. And in this case, we're using also the serializer for the service. So in this case, if I'm going to be using these applications, I'm going to be running the comments very quickly, and we should be seeing that we're able to have them. So if I run the this is the Spring one. So let's go to the Spring and then run the application, and then we are going to be running in another terminal the Quarkus application. So we're going to see Quarkus application. And finally, our Kafka Streams application. Right now, I have three applications connecting to Kafka, or just having them loading, and then I can start posting that some events into those applications. Before that, I'm going to be reading from Kafka Cat. So if I use kcat and then just read from my local host, I'm going to be able to see some events. And then finally, if I send a couple of events, I can send this to Spring. Okay. Okay, let me try to send that one again. Okay, my applications are now running, and then I should be able to send some events. So I'm gonna sending some events to first Spring, and then some events to Quarkus, for example. And now those events were posted, so we can see in the Kafka Cat that we received the Hello Spring and the Hello Quarkus events. And finally, if we just add an order, so the Streams application, it's able to see this change. We will be able to see that the order is processed and it's available and able to read. So if you see those applications are reading from the exact same topic, we are sending information there, but we are able to keep them running with different versions of the same on the same topic from different versions of the schema. So this is how you can handle different versions and the control of this schema. So I'm not using currently security, but you can secure your registry, so you can control who's accessing your schemas, who's able to upload and update your schemas with some control. And finally, I just want to share you some links. So there are a couple of links that are available in the slides that are on scad.com. So you can check how to get started with the service registry. We have a couple of blog posts there. You can go to the GitHub repo also, or you can just go with the community version, Apicurio Registry and Apicurio Studio, where you can find more information on this. So I think we have run out a little bit of time. So I really appreciate that you were staying with us. And I will be around if you want to do any questions or want to share some information. You can paste it in the chat. We can continue the conversation there. Or you can follow me on Twitter at Guerrero, or you can just contact me directly on the platform. So thank you very much and see you around.